So this is limiting reagent worksheet A. The first question says when copper 2 chloride reacts with sodium nitrate, copper 2 nitrate and sodium chloride are formed. So the first thing that we have to do any type of stoichiometry is to write the balanced equation for the reaction. Now I do have that written out for you so we can go ahead to solve problem B. Problem B says that if we have 15 grams of copper 2 chloride, so that's going to be this material called CuCl2, and that is going to react with 20 grams of sodium nitrate. That's formula is NaNO3, and the question wants to know how much sodium chloride can be formed. Well, we've got two different amounts of each of our reactants. And what we're going to need to do is we are actually going to need to figure out how much sodium chloride, which is NaCl, is going to be formed. So this is actually going to require two different steps to be done. So we're going to start with the 15 grams of copper chloride, and we are going to have to figure out how much sodium chloride can be formed. Now, we can actually go ahead and just find out how many moles of sodium chloride are going to be formed because we can actually compare those two to each other. We can just compare moles of sodium chloride made from the copper chloride, and we can compare how many moles of sodium nitrate are made or how many moles of sodium chloride are made from the 20 grams of sodium nitrate. So we're going to start with our 15 grams of copper chloride. If we look at our balanced reaction, it says that we only need 1 mole of copper chloride. So I'm going to need to find out how much 1 mole of copper chloride weighs because I'm starting with 15 grams of copper chloride. So I need the molar mass of copper chloride. So I find that the molar mass of copper chloride is 134.45 grams. The other thing that I need to find out is how much NaCl is going to be made. Well, remember, this balanced reaction tells me that 2 moles of NaCl are going to be made. Well, since I just want to compare moles to moles, I actually don't need to find the number of grams of NaCl. I can just put 2 moles of NaCl on the top of my conversion factor, and that means my answer will be in moles of NaCl because my grams of copper chloride cancel with grams of copper chloride. When I solve that, I find that I get 0.22 moles of sodium chloride are going to be produced from those 15 grams of copper chloride. Now let's do the 20 grams of sodium nitrate. So again, because I'm given 20 grams of sodium nitrate, I need to figure out how much sodium nitrate weighs, because remember, this reaction tells me that I'm going to need 2 moles of sodium nitrate. So if I find the molar mass of sodium nitrate, it's about 85 grams. But remember, again, it says 2 moles of sodium nitrate. So I'm going to have to double that. So now I can take and put that total mass on the bottom of my conversion factor because that's what the balanced reaction tells me I need. That's how many grams the balanced reaction tells me I need. I want to find out how many moles of sodium chloride, and again, the reaction tells me 2 moles. So I'm going to put that on the top of my conversion factor. When I solve all of that, I find that from my 20 grams of sodium nitrate, I will produce 0.24 moles of sodium chloride. So here is what we determined. We were given 15 grams of copper chloride, and we determined that we would be able to make 0.22 moles of our product of sodium chloride. We were also given 20 grams of the reactant sodium nitrate, and we determined from that that we would be able to make 0.24 moles of sodium chloride. So question C asks us, what is the limiting reagent? Reagent is just another word for reactant or material going in. So we've got 2 materials going in. We've got copper chloride and we've got sodium nitrate, and we've got different amounts of each one. Well, which one is going to limit us? Well, kind of think about it like if you've got a recipe. If you've got 15 cups of flour and 20 cups of sugar, well, my 15 cups of flour, I can make 0.22 cakes. With my 20 cups of sugar, of my other material, I can make 0.24 cakes. Well, think about this for a second. The one that I have in red, sodium nitrate, I can make 0.24 moles. I can make more from that 20 grams of sodium nitrate. Now, my other material, copper chloride, I can only make 0.22. So you kind of think of it as like a balancing game. Which material allows me to make the most? Which material allows me to make the least? Whichever material I don't have enough of to make as much as I can with the other material, that material is going to limit me. So in the case of my copper chloride and my sodium nitrate, the material that's limiting me is going to be my copper chloride because I can only make 0.22 moles. I can't make the 0.24 moles like I can with the sodium nitrate. So therefore, the copper chloride is limiting me. The most I'm going to be able to make is 0.22 moles. I will not be able to make 0.24 moles of sodium chloride. The next question asks us how many grams of copper 2 nitrate is formed. So far, we've figured out a couple of things. We figured out that if we have 15 grams of copper chloride, we can make 0.22 moles of NaCl. That means we're not going to make 0.24 moles of NaCl. We are definitely going to be making 0.22 moles of NaCl. So there's a couple of ways that we can go about solving letter D. We can either start with our grams of copper chloride, our 15 grams of CuCl2 that we are given, and we can go and figure out how many grams of copper nitrate are formed from that. We could also start with our 0.22 moles of NaCl that we know are going to be able to be made, and we can figure out how many grams of copper nitrate are going to be made from that. So I'm going to go ahead and I'm going to show you both ways. If we start with our 15 grams of copper chloride, we're going to multiply that by a conversion factor that we determine by looking at our balanced reaction. Since we don't want grams of copper chloride anymore, we're going to put grams of copper chloride on the bottom. Now remember, this is coming from our balanced equation. Well, our balanced equation says we need 1 mole of copper chloride. Well, I can calculate how many grams that would be. 1 mole of copper chloride has a mass of 134.45 grams. So that's going on the bottom of the conversion factor that I'm creating from the information in my balanced equation. Now remember, this wants us to find how many grams of copper nitrate. If I look at my balanced equation, it says just 1 mole of copper nitrate. So take a minute, pause the video, and find out what the molar mass of copper nitrate would be. And since we just need 1 mole of it, according to our balanced equation, that's what's going to go on the top of our conversion factor. So when I calculate that, I find that 1 mole of copper nitrate has a molar mass of 187.87 grams. And so that's going to go on the top because according to my balanced reaction, it's 1 mole. And so I put that on the top. So my grams of copper chloride cancel out. My resulting answer is going to be grams of copper nitrate. And when I calculate that, you should get 20.96 grams. Now, because I know that 0.22 moles of NaCl are going to be made, I could also use that to figure out how much copper nitrate is made. So again, I start with my 0.22 moles of copper or of sodium chloride. Well, because I'm starting with moles of sodium chloride, I'm going to put moles of sodium chloride on the bottom of my conversion factor. I look at my balanced reaction and I see that it says 2 moles of sodium chloride. So I'm going to put 2 on the bottom. And again, I want to find out how many grams of copper nitrate are formed. So I'm using that molar mass because my balanced reaction says that I need 1 mole of copper nitrate. So on the top, I put my 187.87 grams. When I calculate that, I get 20.67 grams of copper nitrate are formed. It's okay that they're slightly different from each other. You can see they are very close to each other, right around 20 to 21 grams of copper nitrate are going to be formed. The last part of this problem asks us to figure out how much of the excess reagent is left over in the reaction. Well, we have to figure out which one is going to be in excess. Well, we determined that CuCl is going to be totally used up to create our 0.22 moles. So that means that we're not going to be able to make that 0.24 moles of NaCl because with the 20 grams of the NaNO3. So that means that we're going to have some extra NaNO3 that's not going to react. That is our excess reagent. So what we want to do is we actually want to figure out, well, how much of the NaNO3 is going to be used. We can use any of our knowns to figure that out. We know we're going to use up all 15 grams of copper chloride. So I can convert from grams of copper chloride to grams of NaNO3 and figure out, well, how many grams of NaNO3 are going to be used. I could also take my 0.22 moles of NaCl and convert that to grams of NaNO3, and that's going to tell me how much I'm going to have to use of my 20 grams. I could also take my grams of copper nitrate that I figured out from the previous problem, and I can convert to the grams of NaNO3 to figure out, well, how much of the 20 grams am I going to be using? I could do it any of those ways. So pause the video, pick a material to start with, either 15 grams of copper chloride, 0.22 moles of NaCl, or 20.96 grams of copper nitrate, or 20.67 grams of copper nitrate, and you want to convert that to grams of sodium nitrate and figure out, that's going to tell you how many grams of sodium nitrate you are going to have to use in order to get that much of our different products, or to use all 15 grams of copper chloride. So once you've completed this, I'm going to show you how to do it, but make sure you pause it and try it on your own. I'm going to do it from going from 15 grams of copper chloride to the grams of sodium nitrate. So remember that when we want to do a conversion factor, we are going to set it up where we start with what we're given, which is 15 grams of copper chloride. So my grams of copper chloride is going to go on the bottom, and I want to find out how many grams of sodium nitrate there are. So remember, we can create our conversion factor based on the information from the balanced equation. So I'm going to need to find out how many grams of copper chloride, which according to my balanced reaction is 1 mole, and 1 mole weighs 134.45 grams of copper chloride. So I'm going to put that there. I want to find out how much sodium nitrate is going to be created. So if I look up here, or how much am I going to need of sodium nitrate, I can see I need 2 moles of sodium nitrate. So I'm going to need to find out what the molar mass of sodium nitrate is, and then I'm going to need to multiply it by 2. That's going to tell me from this information how many grams of sodium nitrate this chemical reaction needs, and then I can put that number up here. So now, based on my chemical reaction, since 2 moles of NaNO3 are needed, that would be 171.99 grams, and 1 mole of copper chloride is needed, which would be 134.45 grams, I can take 15 times this conversion factor, and I will find out how much of the NaNO3 I'm going to need. So according to my calculations, I'm going to need around 19.19 grams of NaNO3, and so it wants to know how much is going to be left over. Well, according to my balanced reaction, it says that I'm starting with 20 grams of it. So I won't have a lot left over. I can simply take 20 minus the 19.19, and I'm going to have about 0.81 grams of NaNO3 left. You might get a slightly different answer, not a ton different, if you do this direction or if you do this direction. But no matter what, you're going to have close to right around 1 gram that is going to be left of that sodium nitrate. You'll get close to this number. It just might be a little bit different, but totally acceptable, somewhere right around 1 gram of NaNO3 left. So on to the last thing. It says that if you have 11.3 grams of sodium chloride formed, then what is the percentage yield? So percentage yield is calculating the actual amount you got versus what you theoretically should be getting, and then you convert it into a percentage. So in this particular problem, we actually got 11.3 grams of NaCl. But according to our calculations, we're supposed to get 0.22 moles of NaCl. So I actually need to figure out how many grams that would be. So I take how much 1 mole of NaCl weighs, and I'm going to multiply it by that 0.22 so that I can figure out exactly how many grams that would be. So NaCl has a molar mass of 58.44 grams. So according to my calculations, I should have gotten a little bit more. I should have gotten 12.86 grams of NaCl. This year, this is just the molar mass of NaCl. I converted moles to grams of NaCl. So when I want to find the percentage yield, what I am going to do is I'm going to take my actual amount that I got and I'm going to divide it by my theoretical, which is how much was I supposed to get, which would have been this guy, 12.86 grams. And then I convert it into a percentage by multiplying by 100. So in the case of our data, we actually got 11.3 grams of NaCl. Theoretically, according to our calculations over here, we should have gotten 0.22 moles, which would be 12.86 grams. So we are going to take 11.3, we're going to divide it by 12.86, multiply that by 100, and that's going to tell us our percentage yield. So of what we were supposed to get, our percentage yield, we were about 88% basically accurate for what we were supposed to get. We got about 88% of the expected amount of sodium chloride.